45, 45, 90 triangles are special right triangles. And out of all the concepts in geometry, I consider special right triangles to be one of the most important because it carries on into finite math, pre-calculus, upper division math classes. What you got to understand is that because they have identical angles, they also have identical sides. So when somebody gives you the side length of, say, 5, you can also match it on the other side and say, well, that other side length is 5. But they will ask you to find all the lengths of this special right triangle, so they'll expect you to find the hypotenuse. What happens is, to find the hypotenuse, you take the side length of your identical sides and multiply that by radical 2. And just like that, that is the answer. However, for most cases, as easy as that sounds, students have difficulties going the opposite direction. Because when I ask for something like, I want to know what these side lengths are given that you have the hypotenuse, that's when people tend to fall apart. Because it's no longer a multiplication. 5 times radical 2 is how we did it. This is a backwards process. Therefore, in order to get this, we'd have to take 8 and we'd have to divide it by radical 2. However, you cannot leave radicals in your denominator, so they're rational. You have to rationalize these in order to get your correct answer. So you have 8. It's divided by radical 2. When you rationalize a denominator, you multiply the numerator and the denominator by the identical thing. This will give you 8 radical 2. This becomes technically radical 4, which simplifies down to 8 radical 2 over 2, because the square root of 4 is 2. Now this 8 and this 2 is going to simplify, which will turn into 4 radical 2. 8 divided by 2 is 4. This is the length of this side and this side. I recommend you practice problems. Give yourselves these sides, multiply by radical 2. Give yourself the hypotenuse, divide by radical 2. Some of your answers will turn out nicer, some of them will have fractions, but again, this is exactly what you're doing in order to find all the side lengths of a 45, 45, 90 triangle.